Business problems. Given the provided architecture and flow diagrams, there are several business problems that have been raised. One of the major problems is the dependence on AWS Lambda functions. One of the proposed solutions is to host the application on EC2 instances, where the environment could be controlled and Dockerized. However, this solution also involves writing all of the SNS components independently of the services because we would want to be completely removed from the AWS environments. The client is currently dependent on one cloud provider for part of its services, but it does not want to be entirely dependent on this provider, nor does it want to be partially dependent on many cloud providers. A fear with going with AWS is the dependence on this provider overall. And while the client is planning on shifting its entire infrastructure to AWS, management still holds the very rational fear of being locked into AWS as a vendor. In my opinion, there are several reasons behind this fear of vendor lock-in. One is the need to avoid a long re-engineering effort if the client ever decides to change providers. This makes sense because it is something companies are dealing with on a daily basis. And if we take it back a level, companies switching from premises services to cloud services are already making a huge move that requires a lot of effort and a lot of process re-engineering. On top of that, they face the fear of switching providers, which requires the same amount of effort all over again. That was one reason. Another reason, what was the first reason? The vendor lock-in, right? Another reason for this fear is the rest in the idea that a single cloud computing vendor will overtake the market and make it less of a choice. In this case, the only solution would be to redeploy an architect for a different vendor. This fear is very valid and a common one among large and small companies. The fear of losing all of your employee data and core application functionality is very real and a good concern for companies to have. While my client was sold on AWS as a vendor, management knew this was a potential end game for the cloud solution and presented their concerns to us in a very reasonable manner. One option was to have a cross-provider solution. One option is to have a cross-provider solution. While this would allow company to use services and products in a cross-provider environment, it is still locked into whatever vendor it chooses for whatever service it is providing. From a business perspective, the vendor lock-in concern is a serious one. In addition, the transformation of large historical data into the cloud also weighs heavy on businesses. The cost may be better in the long run, but looking at it in the short and quick deployment phase, it tends to seem costly and risky. The company wants to be able to use the scalable and flexible resources of cloud providers, but struggles with making changes that could impact the future of the company's infrastructure as well as responsiveness towards its clients. recommended solution. So we covered the business fears, the business problems, the business concerns, the vendor lock-in, the single cloud computer vendor will overtake the market, and the costly and risky process, and all that stuff. What is the recommended solution? The recommended solution to be able to address all of the concerns of the client while still providing the best solution and most cost-effective solution. The best solution would be to develop an application that is provider independent. The best solution would be to develop an application that is provider independent. Can you do a cloud computing solution that works on Google Cloud and on Amazon AWS and on Microsoft Azure? Can we do that? In this situation, the company still gets all of the reward of relying on a cloud provider without wreaking any of the potential downfalls of falling into vendor lock-in. The tricky part of this is implementing the solution correctly. And this is really not only tricky, it's very hard. We have already seen scenarios in which we removed cloud logic from the functionality. This would build from that idea and remove the cloud provider logic entirely and provide it in many forms. For instance, we would have one solution that could switch between AWS, Azure, and Google Cloud simultaneously. Figure 6.5 shows a rough execution of the solution with the first step in the updated overall CSV load flow. So this solution that shows in figure 6.5, right, is implemented without any knowledge of who the provider is. So it should work on Azure, Google Cloud, and AWS. In this flow, we create the same interaction that would happen during the CSV flow, except that the provider is not part of it. This would be appealing to many businesses because they would be able to implement the cloud solution without fear of vendor lock-in, and yet also the fear of vendor lock-in. The way the solution works, you would be able to exist as a company with vendor lock-in and then switch vendors as necessary. For our recommended solution, we will look into a solution that relies on this vendor lock-in, yet knows its weakness enough to code directly for this weakness. Define the approach. While we can identify the obvious business need for an agnostic approach, it is also appropriate to assess the solution on an application by application approach. There's no universal solution. All right. For instance, it might be developing an Alexa Scales application that I want to be accessible by only Amazon Lambda functions in other occurrences. For instance, with the client situation, I would want it to be accessible by all client functions. Or suppose I wanted my code for my Alexa skill to translate to Google Home, Apple Siri, or Microsoft's Cortana. These are very reasonable needs. Companies want their products to be accessible across platforms and products to reach a wider audience. So the serverless architecture makes this jump more feasible than you would think. If you were to try to apply this logic within a virtual machines or applications with infrastructure, we would have a harder time. We would be required to set up entirely different services within these environments and make them publicly accessible. When you think about the different use cases for the agnostic approach, you can see how the code itself, with its underlying logic, shouldn't have to change. The only thing that separates these application environments is the environments themselves. We are going to explore how excuse me. We are going to explore how an agnostic approach might work. In order to do this, I want to start small and then grow as we develop larger applications. To accomplish a scalable and accessible approach to this problem, I think the best way to address this is excuse me, is through small steps. To accomplish a scalable and accessible approach to this problem, I think the best way to address this is through small steps. Serverless framework provides us with a couple of examples of how to create serverless functions correctly and agnostically.